Hi everybody, I'm going to show you solutions to a few more problems from that old final exam. Let's have a look. Alright, this is number 2, so solving 3x plus 1 greater than or equal to 4 times x minus 3. So first we need to solve this for x, so we'll start out by simplifying everything. So 3x plus 1 greater than or equal to, we'll distribute this 4, so 4x minus 12. Now we'll get all the x's to the left and the constant terms to the right, so minus 4x from both sides, minus 4x. While we're at it, we'll subtract 1 from both sides. Alright, so on the left, we're going to get negative x. The 1's cancel. On the right, the x's cancel, and we get negative 13, and it's still greater than or equal to in the middle here. Now we can multiply both sides by negative 1, and over here too, and we get x less than or equal to 13. Remember, when you have an inequality, when you multiply or divide both sides by a negative number, the inequality turns around. Alright, so x less than or equal to 13. Now we need to draw a picture of that. We need to graph it. So here's our number line. 0 is over here someplace maybe. And here's 13. Now we need to indicate all of the x coordinates that are less than or equal to 13. So let's see. Let's start with 13 itself. 13 itself is a solution because this inequality says that equals is okay. And we need all the x values less than or equal to 13, so that's all of these x values over here. Whoa, having a hard time controlling my pen here. Alright, so these are all of the x coordinates that satisfy this inequality. Alright, let's have a look at, so that was number 2, let's have a look at number 3. So number 3, we're supposed to be finding the slope of this line. And the one key thing to know about slope, m, is that it is delta y over delta x. So one nice way to figure out the slope of a line is pick 2 points on the line that are nice points. Points that are exactly on grid intersections count as nice. And then count the move horizontally and vertically from one point to the other. So starting at this upper left-hand point, we can go 1, 2, 3, 4 horizontally. So delta x is going to be 4. And vertically, we'll go 1, 2, 3, 4, 5. So that's negative 5 vertically. So delta y is going to be negative 5. So our slope is negative 5 over 4. All right. One thing to notice about this is if you started at the bottom point and went to the top point, you'd get the same thing for the slope. Horizontally, you get 1, 2, 3, 4. And when you move to the left, that counts as a negative for delta x, so negative 4. And for delta y, you get 1, 2, 3, 4, 5. So you still get negative 5 over 4, either way. All right, there's number 2. Now, I'm out of room here. Let's have a look at number 3. So the problem from number 3 is to find the slope of the line from, let's see, negative 6, 2 to the point 3, negative 1. Okay, so if you're going to find a slope from 2 points like this, it's a good idea to know the slope formula, which is like this: m equals y2 minus y1 over x2 minus x1. Okay, so for this, we'll take this first point to be x1 and y1, and the second point to be x2 and y2. It doesn't matter which point has the 1s and which it has the 2s, as long as you're consistent. Okay, so let's put all of this into the formula. So y2 is negative 1 minus y1, which is 2, divided by x2, which is 3, minus x1, which is negative 6. All right. So in the numerator, we get negative 1 minus 2, that's negative 3. And in the denominator, 3 minus negative 6. Remember, minus a negative is actually adding a positive, so this is 9 down here. And then we should simplify this fraction. Negative 3 over 9, you can cancel a factor of 3. You get negative 1 over 3. Okay, so tomorrow I will run through a few more solutions, and I'll see you then. Bye.